excited. Wonderful to see everybody. We look forward to our Tuesday mornings. Hi, Linda. Yep, I see you.
Good morning. Hi, good morning. How are you?
Fantastic. Super excited. I'm not going to jump ahead and say I'm really excited for our spotlight speakers, but I am. All right.
Hello, everybody. Welcome, welcome, welcome.
Yeah. What a
Hi, Eric. What's up, Linda?
All good.
All right. So good to see everybody. We got Roseanne jumping in here.
Hi, Carolyn. Hi, Jennifer. What's up?
Hey.
Okay. Oh, somebody's talking. All right. So while we're waiting, giving it a few minutes before we get started, does anybody have any great drone stories that they want to do that they maybe had done over a flight or something over the weekend? It was a long weekend.
So are you guys hearing Desi's microphone go in and out, or is it just me?
Just you.
You sound clear to me.
Oh, okay.
So I sound okay.
Yeah, you sound fine, Desi.
Okay.
Okay, then it's me.
Okay.
Great. So announcements.
I do. I have a couple.
Welcome, welcome.
I do have a couple that I want to share. Let's get my page up here. So first of all, everybody knows, hey, women in drones, right? We want to thank you for being here. If you haven't checked out that website for a while, go check it out. There is some cool stuff on there. We've got jobs, we've got connections to make. There's tons of resources. Go check out the Women in Drones website, right? And invite people. That's what we're all about, making that connection, doing that connection with people. So invite your friends, have them come join. A lot to be learned, a lot to share. Another thing that, you know, we don't really actually talk about too often, and you know me, I'm all about safety, right? So if you have not actually checked out this, down a rabbit hole a different way, if you have not checked out the FAAsafety.gov, I highly encourage it. So I am even going to make it really easy for you. I am going to put the link in there. So there's tons of great information in there. San Diego, obviously, we host several webinars, but there's like a really great one going on right now, and it's going to be on Wednesday for night operations. So just a lot of them are online, but that particular one is actually in person. So I encourage you, go check out that. There's a lot of great events also coming up. One of them is going to be AUVSI, a lot of really good things coming up. And so I just want you to get involved and get connected and check out some of this stuff. So that was my big announcement. Oh, but wait, there might be one more. And I'm not going to say too much, but Women in Drones might have a training session coming up. And the only thing I'm going to say, do you remember the wonderful women that were on the Coffee Connection and talked about Miami disaster? That's all I'm going to say. Okay. All right. With that, we are going to segue over. We have amazing company here joining us, and I have been really counting down the days because they are Talyn Air, and I'm super excited that we have them here as a spotlight speaker. We have Jamie and Jordan with us, and I am going to make you spotlight for everyone. Thank you so much for joining us. Hello.
All right, thank you. Hi, thanks for having us. Yeah, I'm Jamie. This is Jordan. I'm the co-founder and CEO of Talyn. We have a super unique dual vehicle Evitol system here for middle mile cargo, unmanned. That's a really short intro. I'll let Jordan take it away from here for a while to tell you a little bit more about it and then jump back in.
Yeah, thank you for having us. It's our pleasure. And you know, thanks to the Women in Drones team, Belinda, Sharon, for pointing us in this direction. I'm going to pull up some slides here, and while I fumble through that process, I just want to say, and we'll probably say it 5 more times throughout this process, we're hiring right now aggressively. And so we appreciate the Women in Drones team for helping us get that word out there as well. How am I looking? Is this a full screen
Yes,
on your end? You
beautiful.
like it? Okay,
It's perfect.
lovely. So we have a very progressive couple years ahead of us, doing some work for the Air Force, and we need more people to come do that. And obviously, a diverse team is going to be something that's absolutely critical towards hitting some of these milestones. So yeah, thanks again. And with that, I'm going to kind of kick off a little bit about what we're doing, why we're doing it this way, and then hand it back off to Jamie, who's going to tell you guys a little bit about the product, since as a co-founder, he would definitely know it the best. So, oh, and please interrupt with questions, either in the chat box, out loud. I'd love for this to be definitely more social and more coffee connection than, forgive the pun, droning on. Yeah. So here's in essence what we're building. We're building a two-stage Evitol aircraft system. Just by the nature of physics, you can optimize for up and down, or you can optimize for lift or drag, lift over drag. What we've done is essentially separated those two. So we can have specialized vehicles that can be going up and down. Rotorcraft allows that vertical takeoff and landing capability. And then at elevation, it releases a fixed wing aircraft with a fully charged battery that's ready to rock and roll and fulfill a longer range, heavier payload mission than you could do with a single vehicle. So by separating those two, we get to cheat physics in a sense. Definitely going to adhere to those laws of physics, but we get to kind of split it up a little bit and fight one battle at a time. So these are 100% battery powered. Non-renewable energy is our aim, and they have zero emissions. We're going to be able to also actually create some of these vehicles at lower costs than some of the competitors out there, because they have to pack all of this into one aircraft. And we get to specialize for each of these specific stages of the route. So what we're doing is decreasing the costs of these package delivery networks, setting it up so that we can leverage existing infrastructure, and really enable a whole new mode of transportation focused on cargo that hasn't yet been tapped into. We have drone folks on here. I would love feedback on this, especially on last mile drones specifically. But what we're looking at here is heavy payloads and long range missions. Again, that's enabled by having these dual vehicles. There are other systems that are going to use fuel, non-renewable consumables that are going to be able to achieve some of this, but it's not going to be a 100% green battery electric platform. Also, by separating, I alluded to it, the economies of scale with these dual vehicles are unique. We can leverage lower cost fixed wing aircraft to really operate the same way that a whole vehicle that has to have all the bells and whistles on it would really drive up those costs. So these are quiet. Maintenance costs are going to be lower. Comparing a combustion vehicle on the ground, let's say a combustion engine automobile versus the somewhat ubiquitous Tesla that's getting out there. We have over 200 moving parts in a combustion engine versus around 15 for an electric vehicle. So that's going to really lower the total cost of ownership and make this very appealing. Just a question for the group. Anybody can chime in here. How do we do on the last mile drones column? Any corrections? Anybody agree or disagree strongly with some of those check marks?
Go ahead and throw the answers and some conversation into the chat. We'd love to hear your feedback. Awesome.
Desi, what do you think? How do we do? Is that right column reasonable?
I'm loving it. Yes. Yeah.
Very good. Appreciate that. All right, let's forge ahead here. So in essence, we talked about using that existing infrastructure, and logistics is built in a couple ways. Generally, hub and spoke is the most common model. There are other nodal-based networks that look a bit more like a spider web. But what we have here is the ability to create reliable and constant flow of goods at a high speed from point A to point B, versus getting these ranges with let's say a Cessna, for example, where you have to go land at a tarmac and then move your goods onto the back of a traditional vehicle and get it to your site. The times are shorter, the touches are less, and it's just a generally more efficient and reliable way to move your goods back and forth. So these are direct paths from where you started to where you want to go. And also looking at a couple applications in the medical space. This enables the quick movement from, let's say, an international airport or someplace where you might have some critically important supplies like organs, large amounts of blood for infusions, and you can get those quickly directly to hospital networks where oftentimes you'll even have those helipad stations on the roof, and you can go right to your door. So pushing the envelope in that sense. So in essence, just kind of summarizing this, and then I'll hand it off to Jamie to talk a bit about what it actually is that we're building. We're creating this aerial pathway between facilities, and people have done a great job. We've all heard about lights out automation in warehouses. These smart warehouses have everything fine-tuned within the roll-up doors. And what you can actually do is start connecting those and have an automated artery between the two that doesn't rely on fluctuating workforces, doesn't rely on ground traffic, which I think a lot of us are LA based. We know that that's a very real variable every day in our lives. And at the same time, we're addressing these ecological initiatives while unclogging the logistics. It's happening at the same time. This is 100% battery electric, which is enabled by the dual vehicle system, which I'll pass it off to Jamie to discuss.
Cool, thanks, Jordan. So this gives a little bit of a timeline of where we are and where we're going. We're currently flying subscale prototypes, which we'll show briefly here in a second. And then we're moving towards much larger prototypes funded by the Air Force. We kicked off a program with them in December to design, build, and fly full-scale prototypes, so 1,000-pound plus aircraft. We should be flying the first Evitol version of that later this year. It's an aggressive schedule, but we're on it right now. And we'll start there with just fixing a pod to that vehicle for some demos, including some dead weight drops where we go smash it into the ground somewhere on purpose, not on accident. And we can use that to fly essentially a more traditional eVTOL mission over short range, lighter payloads. And then we'll phase up into having both vehicles operating together at that point. And then extend the range for cargo flights. So we're all sticking unmanned here. Eventually, in the long-term future, we're looking at transitioning this to passenger flight once we've thoroughly proven out the safety record of the system and made sure that it's operational in all sorts of conditions and safe. So super long-term vision on the passenger side, but it's where we are going eventually. So these are subscale prototypes that we're flying now. You can see this is out in the desert in Southern California on a lake bed. That vehicle that's a little bit fuzzy out there is it's a 12-foot wingspan VTOL aircraft with a fixed wing off-the-shelf RC aircraft hanging underneath it. This was what we call a separation flight, where the two vehicles came apart and then flew a mission, and we're tracking towards demonstrating a docking later this spring. Our Air Force contract there ends in May, so that's the goal. We're going for it sooner, but it's the most technically challenging part of this system for sure. Just to give a little bit more background on how this works, you saw that little infographic in the beginning. So what happens is the two vehicles take off together, standard VTOL aircraft. Fixed wing transition happens, so they transition to forward flight. They're both flying on their wings at that point, and they do a separation. And so that is, unlike the infographic, it's not like it drops or just flies away. So they actually get moving together. They separate gently. And then to do the docking, they come into formation flight with each other on their forward winged flight, and then just slowly decrease the distance. And we use a bunch of sensors in addition to GPS, like computer vision and infrared vision, to really accurately locate the two vehicles, get them to fly together slowly, and then a mechanism that's actively driven goes and gets the RC aircraft, and then they do a hard docking, transition into vertical flight again, and perform vertical landing. So those two flight maneuvers are the key tech development. It's what the Air Force is super interested in right now. The idea here is to de-risk that and then scale up to the point where we can go actually fly useful missions where we're, multi-100-pound payloads over significant distances. And that's when we're into the market commercially. So to give you an idea, I mean, Jordan showed a brief graphic earlier, but this is intended to start with a little bit shorter range over kind of small middle mile distances and then expand over time as we grow the system into larger vehicles with larger payload and larger ranges. And you can really start to build out high density networks with this system. These are intended for, we say it's a network. It's the Evitol vehicle is a node in a network that's operating a bunch of cruise vehicles. So that's where the system really shines. It's not these one-off missions to random points like many of the smaller drones are good at. This is for a high density network with rapid flights that are happening all the time. And the cheaper cruise vehicle that can fly longer range, higher payload, becomes the workhorse, and then the Evitol becomes the tugboat in the port, where it's just doing the up and down portions. It becomes a highly utilized asset rather than getting dragged around the sky, not doing anything for most of the flight. So this is a performance graph that really demonstrates the benefits of the two vehicle system. This is at full scale. So it's not what we're working on now, but as you scale up, these are the performance numbers that you can get. This is on existing battery technology, not something made up, pulled off of Uber Elevate's numbers to say you can get this pack level energy density and performance. And you can really see by splitting it out, getting rid of the mass, getting rid of the drag, getting rid of the power system mismatch. You got a really high power VTOL flight versus a low power cruise flight. Splitting that out into two can get you a lot more range and speed out of the same technology. So that's the genesis of the system. My co-founder and I are former SpaceX engineers, and we're essentially applying the thinking behind stage rockets to aircraft. That's how this came about. Once you're done with the heavy lift portion, get rid of it so you can go on your way. Cool. Yeah. So that's a brief overview of what we're up to. I'd like to re-emphasize that we are expanding the team. We are hiring. We're moving into a new space in the next month or two, out of our small office where we're doing the subscale up into a much larger office where we can build full scale vehicles. We're looking at a 25 to 30 foot wingspan aircraft for the larger VTOL and probably around 10 to 15 for the fixed wing. So we're graduating from prototypes and drones to like serious aircraft, the size of Cessnas, similar masses. And so it's an exciting time to get in. That program is still in conceptual design phase, but we're going to be transitioning to actual build super soon, probably sooner than the team wants.
Very soon.
And we're looking, these are our 4 open roles right now. There's opportunities for other roles and internships for the right folks, and especially as we grow the team and figure out what additional people we need. We're 12 people right now, and so this would put us at 16, so it's still a pretty small team, and there's some room for some additional growth as time goes on. Cool. You have anything else you want to open it up to any questions?
No, that was perfectly summarized. There are a couple questions coming in. I'll lob them at you. So the docking process, is that something that's fully automated? Is that being handled by a pilot and control? What's going on there?
Fully automated. So, some folks look at this and say, like, is this even possible? I'll give one example that was hand piloted. Was Project Phycon. The Air Force did it back in the 50s and 60s. They docked fighters to bombers on a hard mechanism. This is pre-aerial refueling by hand. We do not want to do that. So it's too dependent. It's also a fully unmanned system, and so it'd have to be pilot on the ground. It's too hard. So it's a fully autonomous docking. The secret sauce is in the sensors required to locate the vehicles positioned to each other and the control algorithms to get them to come in together just properly, and on the mechanism that connects the two vehicles for both the docking and undocking. So yeah, fully automated.
Perfect. How about whose radars are we on, so to speak, in terms of some of these larger carriers?
We are just barely on the UPS and FedEx radar. We spoke with them, it must have been 2 years ago, so really, really early. And we're going back to them when we've got these full-scale prototypes up in the air. So yeah, we're just on their radar barely. The plan is to make a much bigger push with them as soon as we're flying the larger vehicles.
Yeah. So I'll kind of piggyback off of that and say we're starting to introduce ourselves again to some of these folks now that we're a part of this 2-year TAC-5 program, that we're building these full-scale vehicles. And again, this is a significant undertaking. So getting these 4 people here quickly and finding the right people to build out this team who are ready to come in and, you know, are dynamic thinkers and want to grow as a part of a company. Jamie alluded to it, but being employee 13 through 16 at a 16-person company means that as we move fast and start building more of these, that's going to be a lot of propulsion upward, so to speak. Yeah.
Too bad puns.
Yeah, I got to lean off the puns. It's not normal. You put me on camera, this is what happens. The puns are not as heavy around the office, so don't worry about that part. Yeah, please fire some more questions our way.
I had a
Happy to answer.
question here about
Another-
FAA certification.
Yeah.
Yeah, always the elephant in the room. So we're kicking off an experimental certification process with these larger prototypes. The FAA cert, we can essentially certify both vehicles independently. And then you have to get a rather unique operations certificate. There is precedent for it under I'm forgetting which part it is off the top of my head, but there's a rotorcraft external load operations certificate where they actually do pick up external loads and drop them. It's not other aircraft, but there is some precedent for that. But yeah, the 2 vehicles individually, relatively simple, although, you know, no certification process, especially in the Evitol world, is simple. And then the operations certificate will be a separate process. So we are working with one group who specializes in unmanned aircraft certification, and then another group who specializes in the operations side of unmanned platforms. So recognize that it will be a big lift, but there does seem to be a path forward.
And well, definitely separate the DoD certifications. The Air Force is being supportive on both sides, not just the DoD, but also the FAA side, which is fantastic asset.
Yeah, we'll be flying in Air Force airspace first before experimentally. Those, you know, as you know, they essentially do a risk-based assessment. Are you out in the middle of nowhere with nobody on board? Cool, we'll go fly it. It's not quite that simple, but you get it.
But it means we get to go fly something unique and we get to do
Yeah.
it quickly, which is
Yeah.
exciting.
And in SoCal also, probably at Edwards.
So as you keep talking, I keep thinking of all these things that I would like to be asking. And so, but what I would like to do is circle back a little bit to the SpaceX and how that was a building block and a foundation for moving forward with this project. Can you elaborate a little bit more on that? Because this is so impressive.
Yeah, sure. So Evan and I, we worked together on the Falcon 9 reentry program, the reentry and landing. So we designed the aft thermal shield on the aft end of the Falcon 9 that protects the bottom of the rocket when it reenters and lands. That was a program that, you know, a lot of people looked at and said, it can't be done. This is dumb for a lot of years. And there was nothing in the math or the physics that indicated that that was a true statement. Which is kind of similar to this program here. We've had folks be like, this is too complicated or you can't do it. when you break it down from a math and physics perspective, it's very doable. It's an execution problem, which is also super hard, but there's nothing that says you can't do it. So I think our learnings there were super important. We were both there for over 5 years, and we've been part of big, audacious aerospace programs that people had heavy doubts on. And so that's kind of given us both the technical experience to go do this, and then the experience of believing the physics and the engineering over the naysayers.
Awesome, awesome. So can you tell us a little bit about some of the hurdles? I know we talked to, the FAA and all that part of it, but how about some of the hurdles as far as like your expectations for going around like TFRs and just trying to make that last mile coming into play?
Yeah, I mean, so a lot of the detail, the aerospace integration, I guess you'd say we're watching developments with a close eye, but not fully engaging with yet. Kind of in the hopes that the UTM and other integration will have further developed by the time we're ready to go into deployment. Something we're watching, but we don't exactly have the bandwidth to be putting any engineering or other person's time into right now.
Yeah. NASA's doing some great work on kind of assessing how that's going to be approached. And actually, right now, from 8:30 to 10 this morning, we chose to be here instead of tuning into that breakout group. So that gives you an indication of where our priorities are at the moment.
Well, thank you. Awesome. Okay, one more time. I want us to go back to the job opportunities and employment that you're actually looking for. Maybe you want to dive a little bit deeper. The location, would they be staying local to your area, or is there travel involved?
Yeah, so we're in LA. The new office will be in the Culver City area. It's almost entirely full-time on site. I'm going to dump a link to our jobs listings in the chat here.
Perfect.
So you can see them in more detail. Yeah, so it's full-time on site. I mean, our travel will be flight test travel. So we test in Southern California primarily. So it's not intended to be extensive travel. The on-site is because it's big hardware that we're testing regularly, and it's can't do it remotely. And the positions that we're highlighting right now are a senior guidance nav and control engineer who will be working on the flight control algorithms to help perform this docking, amongst a lot of other things, but that's kind of the heart of that issue in that role. Flight software engineer, we've got a fantastic one here, and we just need more people there. The software stack is massive. It's one of the big pieces of the secret sauce, and getting those vehicles to reliably do all these maneuvers is super important. The basic coding of make it go here, do this, that stuff's not that hard. It's all the other stuff and doing it properly so that things are safe and reliable is the hard part there. Flight test engineer. So this person would be responsible for things like writing test plans, organizing tests, interfacing with the FAA and Air Force, working on logistics to get out to do the flight tests, and then doing post-flight test data analysis and reports for the team. So that's a pretty interesting role because you get to interface both with government agencies and the team and kind of control the destiny of the flight tests and their success. And then lastly, a dynamics engineer, somebody who'll be working on the aircraft design and analysis for both the aircraft and then the mechanisms that hook the two together, both on the prototypes and then a variety of other SBIR programs we have with the DoD that role will be focused on. So also a breadth of things going on there for that role.
Awesome. Do you foresee training or intern opportunities in the future?
Yeah, so we've got one intern now, another intern coming back this summer who was here with us last summer. So we're not actively looking right now, but we will be expanding to more internships. And then some of these roles are fairly senior, but will also be, we have had like junior folks right out of college join who've been doing a great job. So we do have opportunities for junior folks, and also will be, especially as the team grows, those opportunities will grow too once the core more senior team is in place.
Awesome. I did see another question popped up into our chat. Who would be manufacturing your Talyn aircraft?
Short answer is we will.
Okay.
Yeah, so our background from SpaceX really highlights the fact that a vertically integrated tech stack and manufacturing stack is the way to do things, to make money and do things quickly. By the time you start adding in a lot of third parties, you're adding friction, costs, and time to everything. And while it's a huge pain to build out the capabilities yourself, both on the personnel side, facility side, process side, once you get over that hump, you're in a much better position. So our goal is to do everything that's not super specialized in-house. So, you know, we won't be making chips or anything like that, but
Perhaps Teresa, who asked that question, will be manufacturing the aircraft at some point.
there you go.
Can you elaborate a little bit more about I know on your website, you talk about the batteries, the longevity. That's got to be a huge hurdle to be overcoming. And you're talked about going green and how you're effectively doing that.
Yeah, on the battery side, we are, so like I said, we're baselining essentially existing battery technology for our performance analysis and claims on reagent speed. It's not pie in the sky or 10 years out battery tech. Although we are excited for any developments there, right? Every little bit helps. And we're just starting to figure out what batteries we're going to be putting in the full scale prototypes. There's a debate about ordering versus building our own packs. And like I said earlier, we tend to shift towards building our own, even though it's a painful, challenging process up front. But not the cells. Again, like not that specialized. We would never build cells, but integrate cells into a pack.
Gotcha.
We all
So
have our painful processes when we're starting our businesses, right? So no pain.
Exactly. You might as well just add a bunch of manufactured ones to the list.
right. Also, we have another question that popped up in chat. And will the aircraft be Blue Force compliant?
I don't know what Blue Force is, so.
Perhaps it may be Blue Force compliant. Is there a little elaboration on that, Jim, that you could offer?
Yeah, specifically, are the components manufactured with U.S. allies? And will it be able to be flown over military facilities? That's what Blue Force compliance means.
Yeah, I mean, we almost half of our funding is Air Force. Our test flight will be Air Force. So yeah, we follow all of that so that we can fly in military airspace, sell to the military here in the US.
Awesome. So does anybody have any last questions before we head over to our breakout sessions? I'm going to go ahead and open up some rooms, and I will put both of you into a different room. And that way, if anybody wanted to continue on with the conversation or anything you wanted to add to it, we can do that. And so really quick, like while I'm multitasking, I'm going to pull that off. So,
Cool.
all right. Well, can you, before we head off to those breakout sessions, whoops, somebody did just put one in into the chat there. What are the last mile docking stations like?
So we're doing middle mile, not last mile. And so all of our docking stations will be on, for example, if one of our dream customers is Amazon. So you put a docking station on the roof or parking lot of every Amazon warehouse. It will not be something like in your backyard or at a discrete location that's all over the place. So yeah, middle mile in an established network where lots of things are moving around all the time.
And I think this came up in one of your slides, but what is the weight capacity you're anticipating?
Yeah, we're starting with around 100 pounds of payload. And then, but the early goal is up to 1,000 is the next scale system.
Wow, impressive, very impressive. So, and I did put your link to your website in there. I encourage everybody to check that out as well. Awesome, awesome aircraft. It's super exciting to see it in action on the video that you have on your website. So if they have any other questions or want to do a follow-up or will reach out to you about the employment opportunities, can you put your contact information into the chat? And that way we have the opportunity to save that. And then we are going to continue with this topic and kind of continue on and have it for our room conversation. And so if we could continue on with what hurdles in your area do you foresee for BBLOS and package deliveries? All right, so I'm going to do 2 different rooms and I have both of you in a different room, and that way we can continue conversations. And I can't thank you enough. Great information.
Thank you for having us.
What we're doing. All right, let's go ahead and
Thank you. I'll get up over.
We're inspired with you.
yes.
We're gonna split up so you don't hear our echo.
Okay, here we go. That kind of wraps it up.